in Southern California. This one went all the way up to Northern California, and we were easily working FM repeaters in the Bay Area from Southern California. We can get a signal up from SoCal to the Northern California area via high power and really banging it hard, 5 watts, and we're still able to hit some of the repeaters 300 and 400 miles away. And if you look real carefully at the left-hand side here, you're actually seeing a reflection of the coast, and at sea the coastline looks like it's been on stilts and raised up. Everything is an optical illusion. Look at this ship right here, whose black stack is actually seen here. That's not smoke, that is the high pressure system that is squishing that air, creating an optical illusion. How many have seen a mirage? Look at, yeah, everybody's seen. That mirage is actually the blue sky, comes down and refracts. And it's the refraction that is giving us the VHF and UHF ducting. Now here's a shot that is almost unbelievable. This is a ship station that is coming in, and it is physically upside down on itself. Those of you, if you can get a chance to just take a look at this. This is a ship upside down, and you're seeing a perfect mirage. On Marine VHF, it was reported they were hearing this ship making radio calls hundreds of miles away, and that's on 156 megahertz, just up from our 144 megahertz. So pretty amazing that we get that kind of an illusion. And here it is, live action. And you can imagine after a heavy night of celebrating, you look out there going, oh boy, I'm going back to bed. When you see a ship coming into the harbor upside down, on top of itself, right side up. Great. So the inversion occurs during usually early evening hours and early morning hours. What happens between 12 and about 3 o'clock, most parts of the country, the wind picks up. We either get a sea breeze coming in, or for those of you in other parts, you get air coming in from a usual direction. And when we have a lot of wind, you're not going to have great tropospheric ducting. Remember that to keep that band absolutely straight, going for up to 1,000 miles away plus, we need to have that with no wind at all. And that usually occurs in July. Yes, sir. Real loud so I can hear.
Just how often? Are these photographs you've taken?
Say again.
Are these your photographs?
Let's see. Some of them were my photographs, not the one of that ship. That was in Europe.
Okay, how often do you see this in Los Angeles area?
In Southern California, we look out on the ocean, and I see it every July for 10 or 15 days in the month. And when I look out there and I see this band of brown air, have you landed in an aircraft and you're coming down and you see that brown air, and then all of a sudden you're in that thin band of brown air, and here's a seagull going, yeah, that's smog, and then you're below it, and it's not as clear, but that gives you the idea of that duct. Okay, next one, Tracy. Here you see, and I think this is one of my shots, yep, where the land actually is gobbled up by the ocean. And again, we're showing you these visuals because we can't visualize radio waves, but by golly, we sure can with optical rays. For those that monitor the weather, what we're looking for, if we're trying to pick up a signal from Hawaii, is the weather pattern that shows almost undisturbed air between the west coast and Hawaii, or for those in this area, all the way down to Texas, and ultimately all the way down to Florida. Every July and August, stations in Texas easily talk to stations in Florida. Florida many times will talk to stations up at New York and further north, and that's all due to tropospheric ducting.
From Hawaii down here.
Yeah, Hawaii's right down there. And that's that undisturbed layer. And while it looks sort of ominous, those are low clouds that only go to about 500 to 600 feet, and that is what creates it. For those that want the very best at forecasting tropospheric ducting, it's called Hepburn, Hepburn. And Hepburn report is the one that on the internet gives you these colorful analysis of VHF and UHF propagation all over the world. All right, next one.
I just did the next one. So.
Oh, okay.
And here.
Yeah, let's see. Yeah, that one sort of made it to white, but you can see there's a lot of undisturbed or a lot of disturbed weather in the area. It has to be absolutely clear to be able to get a 2-meter signal to Hawaii. And if ever you wonder what a 2-meter signal all the way to Hawaii sounds like, oh, the wind's blowing. No wonder I'm not hearing anything. All right, now let's try it again. See if we can get Hawaii. Did you hear it? No, there's no code there. But, nope, still no code. You're on the west coast with a little 11-element beam. The beacon in Hawaii, there it is, thank you, great. That Paul Lieb, silent key, but what a great guy. He's on a shack on the side of an active volcano. What ham would work DX on the side of an active volcano in Mauna Loa? Paul Lieb, and this is what makes it so exciting. The beacon is on 24 hours a day, and there are beacons all over the United States on 2 meters, 432, and 1200. And what we use to try and pick the signal out is if you have an older VHF, UHF radio, FM, or in this case sideband, you want to do digital DSP. But without DSP, let me go back. Without DSP, so DSP, digital signal processing, really makes a difference. And we tune into the beacon, and we start hearing some of the Hawaiian repeaters coming through. On 147.030 is one of the biggies. And along the Hawaiian Islands, you can see where we're trying to get a signal from Southern California via Tropo. And to do so, we even try on microwave, and they've gone as high as 5 gigahertz on microwave. So pretty good. One time we had an opening so strong between here and Hawaii. Which month do you think it was in? July, that's it. Was the wind blowing? No. Was it hot and sticky in Southern California all the way? Yes. So it's a perfect tropo weather. But it could be anywhere in the country. Those of you from the Midwest, you can get signals thousands of miles away on those windless July days. One time it was so good on 440 band, I said, let's go to amateur television. And we went over to ATV. And this is this is fast scan amateur television, analog, 6 megahertz wide on 430, I forget what the frequency is, but that was the beacon I was picking up from Hawaii. So amazing, and it lasts for several times. We've tried it as high as 10 gigs, we've not made it yet, but we did do 5 and 3 and some of the other bands. And so here's a Southern California ham parked on the side of a hill, and I said, don't you want to be higher? I mean, he was on like an 800-foot hill, but it was only up at 200 feet. He says, take a drive and listen to the Hawaiian weather station. Down on the deck, nothing. 300 feet, it was booming in. 400 feet, it was getting weaker. And 500 feet, couldn't even hear it. Get back down to 200 to 300 feet, and you're in the duct. And once you're in the duct, it's getting a little warm in here, and the eyes are beginning to water because you're right in that smog belt. That's the time you get on 2 meters and 432. If you have an FM radio, go on to look around for repeaters on the band. But look at this. That guy's crazier than we are than going out there and putting up all these antennas, but he's going to have a great time. That's Chip N6CA, who's one of the main people behind the Hawaiian beacons. So you have to be cautious that you don't have the police coming up going, what the hell are you doing with all those antennas? Quite frankly, many times now with Homeland Security and all the things going on, have your ham license handy because they see this stuff, and you know we have a huge potential of insurgent coming in from the ocean. So they want to know who's doing what with antennas seemingly pointed in a strange direction. So that's fun. You don't need a huge antenna for tropospheric ducting. How many have a 2-meter vertical on your vehicle? You're set. Next hot day in what month? July, when the wind is not blowing and the temperature, and you see that band of what color air? Brown. Well, brown in Southern California. You guys have such clear air out here. You just look for something that looks a little different. But a little 2 or 3 element beam, sure, that'll do fine. Polarization is important. That was the big question we had was, will a signal inside the duct begin to rotate polarization? The answer is not that we have found. If it is a vertical polarized signal coming in, you're best picking it up on that vertical off of your mobile unit. So those of you that just have just a vertical on your vehicle, you have just as great a chance of working some real DX. The real DXers will do single sideband, and they'll go on the 2-meter band or the 432 band. And those contacts on single sideband will sound a little bit like...
There is 5 degrees. We are right on.
There we go. First of all, look at beam heading to see how important beam heading is. That's the beacon.
Here we are right on. 0 degrees on. There is 5 degrees off. 10 degrees off.
Almost disappears.
15 degrees off.
Gone. So we know that if you have a beam and you're trying to work, let's say Florida or Texas from this area, you've got 15 and 15, you have a total of 30 degrees latitude, but polarization's important. If you're trying to pick up a repeater in Texas or New Mexico, vertical polarization. If you're horizontal, you're going to have as much as a 10 to 12 dB loss. You probably won't even hear it. But on the weak signal operators, 144, 275 to 144, 300, we use horizontal polarization, but even that's changing. So we don't know if it's going to stay that way or not, but polarization changes. And when trying to monitor for a beacon or for a weather station and so on, your squelch has to be turned off. Take a listen with squelch on. Turn the squelch off.
But if I turn the squelch all the way off.
Thanks, Gordo.
Beacon comes in loud and clear.
So that beacon is coming in 2,500 miles, but you can get the same thing here. You don't have to live down to the seashore. That's Chip, K7 Juliet Alpha, who's also great on tropospheric. We go down to the beach. And again, we're at a low elevation because many times the signal from Hawaii will just come in right at about 200 feet or less, and we're right at water level. Here on the hard sand, you'll find that Tropo generally is anywhere from 200 feet up to about 800 feet. Yes, sir?
Now, your earlier slide showed the beacon in Hawaii. I couldn't read it whether it was 3,000 something or 5,000 something feet.
Yeah, now that's a great point you raised. Thank you. Tell me your call sign.
WA6ZTY.
Ah, there we go. His observation is the Hawaiian beacon is up 5,000 feet on the side of this active volcano. Yet, and any lower than that, and we barely hear it. We've had mobiles go all the way from Hilo up to the hill, and when they get up to about 4,000 feet, then they begin to come through. At our end of the circuit, it's slanted. Our end, we're down about 200 feet off the deck. That's where we have best reception. If we go to this, we have hills. In fact, Tracy lives on one. At 5,000 feet, he's going, I don't hear squat. And I said, well, you're too high. No, I've not had anything
California.
but 7-Up today. So, but many times that tropo duct, for unknown reason, will go high, and he says, I'm hearing the beacon, and we're not. Yes, sir.
Is the inverse possible then? If we are 5,000 feet on the west coast, do they hear us on the 200-foot there?
Okay, his question was, what if we reverse that and we were up high and we're trying to talk to a Hawaiian mobile? No, for some reason, that particular duct is a slanted one, going over ocean waters. However, the ducts between here and New Mexico and Texas, as well as Texas to Florida, as well as Florida up to Nova Scotia, as well as Chicago, talking down to Louisiana, those seem to be very broad, and many folks only need to go 200 or 300 feet at both ends of the circuit. So you almost have to be in the duct. And for some reason, the duct out on the hard surface of the earth pretty much stays level, and it will go up and down a little bit. And as long as that high pressure system stays in check, will continue. So Paul Lieb is one of the record holders, again silent key. The height of his antenna was 8,200 feet, so even above 5,000, 8,000. Yet his signal comes all the way down to about deck level at this end. Okay, you can get rid of that guy immediately. All right. So a couple of little wrap-ups here.
Watch out, don't operate.
7-0. And if you listen real carefully.
All right. Got one last little demo. The question was raised, how important is the modulation scheme? And we're going to take a listen and see what this sounds like.
On 0 degree.
Oh, no, we've already done that one. Hang on, I know it's here. All right.
Now there's new digital technology.
Yeah. Analog edit.
Analog rules.
So what we've learned today is that once the band is open, it will support, as you saw, television. It will support FM, good old frequency modulation. It will support digital. Now, we didn't know if there would be enough distortion of the signals to support FT8 or some of the digital modes, and the answer is no problem. So it's like an open waveguide. You just have to be in the area where that opening is maybe down here at deck level. I think we're up at what, about 1,000 feet? Is that our elevation here? 800, okay. And to get a signal down to Texas or Utah, up to Utah, again, as long as there's not a big mountain range in front of you, you're in good shape. That's why on the West Coast we won't hear anything over the mountains, in that it just blocks the tropo duct and it breaks it up. But if there's a straight path, even though it's on the other side of the Earth, you're going to have a good signal. So our tropospheric ducting is, yeah, there's a lot of weak signal operators on single sideband, but there's plenty of opportunities to work repeaters literally 1,000 miles away in July and August during the tropospheric duct. All right.